Gaylor Charlie, welcome back. Today I'm taking you into one of the most unsettling shifts happening in modern warfare, a battlefield where the most persistent hunters don't need food, water, sleep, or courage. They don't panic under artillery, they don't freeze when drones buzz overhead, and when they take a hit there's no blood, only broken metal. Ukraine's unmanned ground vehicles, or UGVs, are no longer a niche experiment. They're becoming a real layer of force on the front lines, especially across eastern Ukraine, where simply moving a box of ammo can be a life-threatening decision. This isn't a distant future of war concept anymore. It's happening right now, and it's changing what it means to hold a trench, to resupply a position, and even to assault an enemy strongpoint. If you're new to Gaylor Charlie, subscribe now so you don't miss deep, story-driven breakdowns like this. And as you listen, I want you to stay with the human reality behind the machines, because the point of these robots isn't science fiction. The point is to keep soldiers alive while still fighting effectively. Question 1. If you were commanding a unit that's outnumbered and stretched thin, would you trust a ground robot to take the riskiest job on the line? Let's start with the basic truth of eastern Ukraine's battlefield. Overhead drones, especially fast FPV kamikaze drones, have turned movement into exposure. A pickup truck that once meant speed and safety can become a burning marker in minutes. A medevac run that would have been dangerous in any war becomes borderline suicidal when a camera in the sky can call in a strike, or when a buzzing drone can sprint toward a moving target. That's where UGVs begin to matter. Not as a flashy new toy, but as a practical answer to a brutal problem. How do you move supplies, recover wounded, or rotate equipment under constant observation and fire? For commanders, unmanned systems have always carried an obvious promise. Any task that is too dangerous, too expensive, or too difficult for a human can be handed to a machine instead. On paper, that includes the grim essentials: ammunition delivery, food and water runs, casualty evacuation, reconnaissance, mine laying, and retrieval of the fallen. But paper doesn't win wars. The real test is whether the machines can do it when mud clogs tracks, when signal is jammed, when batteries die in freezing nights, and when the enemy actively hunts anything that moves. Ukraine has been experimenting with UGVs since the early stages of the invasion, but their role grew sharply as the country organized around unmanned warfare at scale. The logic is straightforward. When manpower is limited and the front is long, a robot can fill a gap that a rifle squad simply cannot. It can sit in a dangerous lane and take the first contact. It can carry weight that would exhaust a soldier. It can run a route one more time, even after the previous run ended in smoke. At first, many soldiers didn't take these ground robots seriously. Early platforms were slow. They looked awkward. They seemed like something that would break at the worst moment. Some troops laughed at them as they crawled along while normal vehicles rushed past. That skepticism didn't vanish because engineers gave a motivational speech. It vanished because the battlefield punished anything familiar. As drone warfare intensified, the vehicles Ukraine relied on, especially the pickup trucks used for quick supply runs, became prime targets. A truck is fast, yes, but it's also loud, predictable, and visible. On a front line soaked in electronic warfare and surveillance, speed is not always protection. Sometimes it's a spotlight, and then something changed in the daily math of survival. A slow robot that can be remotely driven at night, hugging cover, using a low profile and a smaller signature, becomes a kind of moving insurance policy. Not perfect, not invincible, but different enough to survive in places where a human-driven vehicle is basically an invitation. So Ukraine fielded more of them. Logistics drones on tracks and wheels that could haul loads, move steadily across broken ground, and keep running routes that would otherwise chew up vehicles and people. Some of these systems are compact, low to the ground, built to crawl through uneven terrain. Others are larger, built like workhorses, designed to carry the kind of weight that turns resupply from a desperate sprint into a manageable routine. But logistics is only the first chapter, because once a robot can reliably reach the line, the next question becomes unavoidable. If it can carry ammunition, can it carry a weapon? If it can evacuate wounded, can it also suppress the enemy while humans reposition? If it can move mines, can it also plant them under fire without risking an entire team? That's where the story becomes darker and more decisive. Armed UGVs are an attempt to trade metal for manpower. A machine takes the exposure. A human operator stays farther back, behind cover, controlling the platform through cameras and sensors. If the UGV is destroyed, it's a loss of money and equipment, not a loss of a life. And on a front where attrition is the daily rhythm, that trade can be the difference between holding and collapsing. One of the most common weapons mounted on these platforms is the heavy machine gun. Not because it's glamorous, but because it's brutally practical. A heavy machine gun offers range, penetration, and intimidation. It also creates a psychological effect. When troops hear a heavy caliber ripping through cover, they often assume armor is nearby. That assumption forces decisions: retreat, reposition, or panic, even when the armor is nothing more than a disguised robot with a turret. But mounting a weapon on a robot isn't as simple as bolting steel to steel. A machine gun is built for a human crew that can clear jams, swap belts, and feel the rhythm of the weapon. A robot can't do that, at least not easily. If the gun jams, a human still has to intervene, and that can mean risking a recovery mission in exactly the dangerous area the UGV was meant to spare. So engineers work around the limits. They try to preserve the original weapon design so reliability stays high. They add remote triggers, electric control for the turret, and software that turns a basic machine gun into a precision system. The platform can calculate distance, account for ammunition type, estimate wind, and track target movement more consistently than a stressed soldier behind a sandbag wall. Then there's the next layer: machine vision and artificial intelligence, used not for autonomous killing, but for spotting. The system can scan a sector, patrol an angle, detect motion or heat signatures, and alert the operator. The human still makes the firing decision, partly for safety and identification, and partly because the battlefield is chaotic, with friendly forces, civilians, and shifting lines. Even with AI assistance, the invisible enemy remains the signal war. Electronic warfare in Ukraine is relentless. Jamming can turn a strong connection into dead air, and when a UGV loses link, it risks becoming a stranded chunk of metal, or worse, a prize for the enemy to examine. That is why so many Ukrainian units don't just accept factory standard systems. They modify them. They strip out vulnerable analog controls. They rebuild frames. They reroute wiring. They install more resilient digital links, encrypted channels, or alternative communications. Some teams integrate satellite terminals or cellular-based solutions where possible. This is not a clean lab environment. It's wartime engineering, messy, fast, and driven by lessons paid for in damaged machines. Now, machine guns are only part of the picture. Automatic grenade launchers are another system that makes sense on a UGV, especially because they can engage targets from covered positions and arc fire into areas a direct fire gun can't easily reach. That capability matters when trenches, tree lines, and shattered buildings break up sightlines. But grenade launchers bring heavier recoil, more weight, and a new demand for stabilization. A lighter robot can literally be thrown off aim by its own weapon. Vibration loosens bolts, stresses electronics, and turns precision into scatter. After missions, crews often have to inspect and secure everything as if they're rebuilding the machine every time it returns. And still, Ukraine pushes forward because the payoff is immense. Imagine the classic high-risk task: moving a heavy weapon system and ammunition to a firing position. With humans, it's slow and exposed. The group hauling it can be spotted by drones and struck before they ever fire a shot. A UGV can haul the entire load at once and arrive ready, reducing that window where soldiers are vulnerable. There's another tactical problem Ukraine faces. Russian forces often advance by pushing large numbers forward, split into small probing groups. The goal is to find weak points, force defenders to spread thin, and slip through gaps. Countering that kind of pressure demands speed. Defenders must shift, set up new positions, and camouflage quickly, often under drone observation. A robot with a weapon doesn't need to rest, it doesn't need to drink water, it doesn't need a rotation. If it's pre-positioned, it can open fire instantly, buying time for humans to set up properly. And if the enemy hits it, the operator is still alive. But here's the hard truth. Building a robot that fights anywhere near the level of infantry is extremely difficult. Infantry adapts. A soldier crawls, listens, feels, improvises. A soldier fixes a jam, drags a wounded friend, changes plans in seconds. A robot follows systems, sensors, rules, and links stability. So Ukraine's armed UGVs today are not robot soldiers in the Hollywood sense. They are remote weapon platforms and robotic mules that extend human capability. That said, the pace of improvement is startling. Ukraine's UGV ecosystem has grown in both numbers and diversity. Instead of a handful of experimental models, the force now draws on many designs produced by dozens of manufacturers. Some systems specialize in hauling, some in evacuation, some in mine work, some in direct combat. The variety matters because battlefields are not uniform. Mud, snow, rubble, forests, trenches, and broken roads all demand different mobility. And the production model behind this is one of the most important lessons of the war. Ukraine is operating in something like an emergency innovation cycle. In many countries, weapon development is slow, bureaucratic, and dominated by long procurement timelines. In Ukraine, that pace is impossible. Units need solutions immediately. Feedback from soldiers is fed directly back to makers. Designs are adjusted, shipped, modified again, and pushed back into use. This cooperation between frontline troops and developers is a force multiplier. It means machines evolve based on real problems. Which camera angles fail at night, which antennas get cut, which chassis flips on cratered ground, which tracks clog in mud, which wheels can't climb a trench lip. And that leads to a surprising conclusion. Compared to tanks and crude armored vehicles, many ground robots are not that hard to build. They don't need space for crews, they can be compact. They can be assembled using commercial components where military parts are scarce. Some cost a few $1,000s. Others cost tens of thousands. Even the expensive ones often cost far less than a traditional armored vehicle. And the loss calculus is different because there's no crew inside. Now widen the lens and the implications spread beyond Ukraine. For decades, militaries talked about unmanned systems as a supplement. A few robots here, a few drones there. Ukraine is demonstrating something else. Unmanned systems as a core branch of warfare, integrated across air, land, and sea. It's not just a tool, it's a structure, with dedicated operators, maintenance pipelines, and mission planning. But integration brings a new challenge: tactics. Coordinating unmanned ground vehicles alongside infantry is not the same as coordinating only humans. Commanders must understand signal limitations, terrain constraints, battery life, recovery needs, and mechanical failure modes. A headquarters can't just order a robot to do what a squad would do. A robot needs a mission shaped around what it can actually achieve. Defensive use has matured fastest. In defensive layers, armed UGVs can act like remote observation posts and firing points. Positioned back from the most dangerous zone, they can cover approaches, suppress movement, and hold lines with fewer human bodies in the immediate kill zone. They can remain in place for long periods, scanning and waiting, while operators control multiple sectors from shelter. Offense is harder. Assaults require rapid changes, close coordination, and moving through areas that the enemy is actively hunting. For now, many UGV assault roles resemble reconnaissance in force. Robots advance first, provoke fire, reveal positions, and pin the enemy while humans maneuver. In some operations, explosive-carrying ground robots function as controlled demolition, driving into fortified positions and detonating, clearing a path without sending soldiers into the first wave. These missions are not clean. They are brutal. They are also effective, and once the concept works, it scales. Larger platforms begin to appear, machines that can carry more ammunition, mount heavier modules, and behave less like a weapon on a cart and more like a compact fighting vehicle. Some designs are built to handle multiple guns, others are being prepared for heavier cannons. The aim is clear: make a robot that can provide sustained fire support without placing a crew inside an armored box. But even as these systems grow more powerful, the most important constraint keeps returning: communication. A UGV that loses link can become dead weight. A stranded UGV may have to be recovered, which risks soldiers. A captured UGV may be studied, which risks tactics. So Ukraine and others explore multiple solutions at once. Better encryption, more robust repeaters, layered control options, and a push toward autonomy for limited tasks if connection drops. Autonomy sounds tempting, but autonomy in combat is a minefield of reliability and identification. A robot that mistakes a friendly for an enemy is unacceptable. A robot that drives blindly when GPS is jammed can be lost. So the realistic direction is not full independent warfare overnight, but a gradual rise of assistive autonomy, machines that can stabilize, aim, patrol, return home, or hold position even when the operator's link is imperfect. Now let's step back in time, because the idea of ground robots in war is older than most people realize. The concept of remotely controlled explosive vehicles goes back more than a century. Early 20th century experiments explored radio control and mechanical guidance, and in the decades that followed, major powers toyed with remote tanks and uncrewed platforms. Most programs collapsed under the weight of cost, fragility, and limited communications. The dream was bigger than the technology, but modern sensors, cheaper computing, compact motors, battery advances, and mass-market electronics have changed the equation. The same consumer supply chains that produce cameras, radios, controllers, and processors can be adapted into battlefield systems. Ukraine, forced by survival, has become an extreme test environment that accelerates what would normally take decades. And that brings us to one of the most terrifying evolutions of this war: the creation of drone-dominated kill zones. In some sectors, the space between lines is no longer just dangerous, it's systematically hunted. Reconnaissance drones search constantly. FPV drones wait to strike. Ground robots may run routes or deliver explosives. Mines, wire, and obstacles funnel movement into predictable lanes. The effect is that large areas become traps where the enemy is spotted, tracked, and destroyed before reaching a real objective. Think through what that means for an attacking force. Traditional maneuver relies on moving men and equipment forward, gaining footholds, and reinforcing success. But when movement itself triggers destruction, attackers are forced to crawl, split into tiny groups, and hope to slip through. Even if a few make it, they arrive exhausted, undersupplied, and without reliable support. A foothold becomes a coffin. Ukraine's approach in places like the Kupiansk sector has been described as building a wall, an extended zone where drones and sensors deny the enemy freedom of movement. And it's not only aerial drones, it's layered defense, terrain shaping, obstacles, mines, surveillance, remote fire, and rapid strike assets that punish exposure. This kind of system is a response to a deeper Ukrainian problem, manpower strain along a very long front. If you can deny movement with machines, you can hold with fewer people. If you can attrit enemy assault groups before they reach your trenches, you reduce the demand for constant infantry contact. It's not a magic solution, but it changes the ratio. And that ratio is the core of the entire robot war. Russia can throw men into a grinder. Ukraine, facing shortages, seeks to throw machines into danger instead. Each robot lost is a financial hit, an industrial replacement, a maintenance burden. But it is not a funeral. Now, none of this means robots win wars alone. Robots still need humans to plan, maintain, recover, and operate them. They need power, parts, and training. They can fail, they can get stuck, they can be jammed, they can be ambushed, disabled, and captured. But the trend line is what matters. The battlefield is becoming an environment where the side that can mass cheap sensors, cheap strike systems, and resilient control networks can dominate space without occupying every meter with human bodies. In that environment, a ground robot is not just a machine. It is a way to project presence, an artificial soldier that can hold a firing lane, move supplies, or detonate in a fortified position. Other militaries are watching closely. Some are trying to replicate the model. Large numbers, faster iteration, cheaper platforms, and a willingness to accept losses of equipment in exchange for tactical advantage. Traditional procurement logic struggles here because it was built around expensive, perfect systems that must be protected. Ukraine's logic is different. Make systems good enough, make them in volume, and accept that in a drone-saturated war, everything is expendable. And that shift could reshape the next decade of military planning around the world. Question 2. If wars can be fought with operators far behind the line and machines taking the risks, does that make conflict more likely, or does it make it harder to sustain? Before we close, there's something I want you to hold on to. When we talk about robot armies, it's easy to get lost in specs, payload, range, caliber, sensors, autonomy, but the lived reality is simpler. A ground robot means a soldier doesn't have to drive a truck through a kill zone. A ground robot means a wounded person might be retrieved without an 8-person team risking their lives. A ground robot means a defender can cover a sector with fewer people. And in a war defined by drones and attrition, those margins decide outcomes. If this narration helped you understand how Ukraine's UGVs are changing the battlefield, logistics, firepower, tactics, and those drone-dominated kill zones, drop a comment. What part surprised you most? And again, this is Gaylor Charlie. Subscribe for more story-driven breakdowns of modern conflict and the technology reshaping it.